All right, welcome to day 2 notes for 7-2 operations with matrices. Today we are going to talk about multiplying matrices. First issue with that, if you are going to multiply, the number of columns in the first matrix has to equal the number of rows in the second. If that doesn't happen, you are out of luck. So I'm just going to switch to the line tool here. What we're talking about is right there. The column, when you have your order, it's row by column. The number of columns in that first matrix has to equal the rows in the second one. Since that is the case, we can multiply these together. Your result of your answer is going to be the outside numbers. So since these are the same, your result is going to be a 3 by 3 matrix. Same deal here. I got 2 columns with this one, 2 rows there. I can multiply. I will end up with a 5 by 4. Third one, 4 columns by 4 rows, so those numbers are the same. We will end up with a 3 by 1. And the last one here, you can see 5 does not equal 2. So we cannot take a 3 by 5 matrix by a 2 by 5. So that is not going to work, and there is no order for the resulting matrix. So with that said, we'll go to our next slide here. You can see we got two 2 by 2 matrices for right now. Again, typically with a 2 by 2, we won't use the calculator. You can, but it's really not needed at this point. When we multiply row by column. What that means is I am going to take this first row here times the first column there. So 4 times -3, 7 times 12. First row, first column, that's where that number is going to end up. So you can see my work there. So I did first row, first column, and we'll simplify this in a second. Then right here is going to be first row, second column, so 4 times 9, 7 times 6. You can see we put that number in the first row, second column. And then we're going to do the same thing here for the second row. So second row times the first column. So again, second row in A times the first column in B. So you see that there. And second row in A times the second column in B goes in the bottom right. And when I simplify that, here is my answer. So -12 plus 84 is 72. When I multiply these two and add them together, I get 78. And the second row, 3 and -9. Anytime we see ones or zeros, we like that because that helps obviously make it a little easier with multiplying. But again, when you multiply row of the first matrix times the column of the second matrix. Okay, so here again we have a 2 by 2, and we're going to do A times B. You can rewrite it like I did in the last slide, or we can just put our work off to the side here. So again, first row times first column, that's the work you see right there. First row times the second column right here. And then we have our second row work. Second row of the first one times the first row, and second row of A times second column of B right there. And if we simplify here, then we can get right to our answer, which is going to be 22, 16, 36, and 12. So how you organize that, whether you do the work off to the side like that, or if you do the previous slide and actually write it in a matrix like this, and then your answer, that's fine. Either way works. Again, the key, those matrices have to be the same order. They have to be square matrices, or the number of columns in the first one has to equal the number of rows in the second one. Okay, so here we have 2 matrices that are different sizes. Got a 2 by 2 and a 2 by 3. The number of columns here equals the number of rows here, so we can multiply B times D, and we are going to end up with a 2 by 3 matrix. So again, first row times the first column, first row in B times the second column of D, and first row B times the second column of D. And when I talk about the columns, you always take the first number in the row times the first number in the column. Second number in the row times the second number in the column. And then when we do the second column, same deal. -3 times -7, 9 times 2, third column. First one times first one, second one times the second one. All right, same thing for the bottom row. So 12 and 6, 12 times 1, 6 times 5, 12 times -7, 6 times 2, 12 times 0, 6 times 3. So here's our work here. Whether you rewrote as a matrix or did off to the side, that's fine. And then I am going to combine these numbers here to get my answer, which again is going to be a 2 by 3 matrix, and that's what we get right here. And that's what we should get. When you start multiplying, you'll get a little bit bigger numbers usually than when we add or subtract. That's okay. You might even see some 3 or 4 digit numbers. Don't freak out about that. When you start, again, multiplying 2-digit numbers is going to get big in a hurry. Okay, if you have your notes from day one, we are going to use our matrices from day one. So that A, B, C, D, and E that you had on the first couple pages of the notes from 7-1, those are the matrices we're going to use right here for when we do A, B, B, E, and C, D. All right, so again, you see those here. This is the ones we're talking about, same as yesterday. And we are going to start with A times B. Now, again, with a 2 by 2, sometimes you can do this work in your head. So I didn't show all the steps here, but 4 times -3 is -12. 7 times 12 is 84. So -12 plus 84, that's where the 72 came from. 4 times 9 is 36. 7 times 6 is 42. Add them together, 78. -1 times -3 is 3. 0 times 12 is 0, so 3. -1 times 9, -9 plus 0. There you go. And so that's the same steps that I am going to apply for C times D and B times E. I'm just going to slide this down just a tad here. So when you do C times D, this is a 2 by 2. This is a 2 by 3. So again, we can multiply those. We're going to end up with a 2 by 3. And again, you see this top number in C is a 1. So 1 times 1, 14 times 5. So 1 plus 70 is 71. -7 plus 28 is 21. 0 plus 42. Then we'll go ahead and do the second row. So -3 plus 50 is 47. 21 plus 20 is 41. And 0 plus 30, 430. And then B times E, we're going to do the same thing. So again, I got 2 by 2 by 2 by 3. I'm not going to go through all the steps here, but you can see the final answer. So as long as you have B and E there, again, row times column to get the top 3 numbers here, and then second row times the columns to get the bottom 3. Okay, here, separate example, matrix A. Notice we have A written twice, and the reason for that is we are actually going to do A squared. And where a lot of students screw this up is they just square these numbers. They're like, oh, A squared, and they'll do 4 squared, 7 squared, -1 squared, and 0 squared. And that's really not the answer. What you're doing is taking matrix A times matrix A. So we still have to go row times column. So 4 times 4, 7 times -1, 4 times 7, 7 times 0. Then we do the second row, -1 times 4, 0 times -1, and then second row, second column right here. So in reality, when you do A squared, you're multiplying those matrices, and you can see here we get 9, 28, -4, -7, which is way different than if you just squared these numbers. If you just squared them, you'd get 16, 49, 1, and 0, and clearly that's not the answer for a squared. This slide, same idea. Now we just did matrix B, but again, B squared. So we're going to multiply the matrix times itself. So row times column again. So first row, first column, first row, second column, and then down here, second row, first column, second row, second column. Going to add these together, and when we do that, there is B squared. As always, if you need to pause, you need to rewind, go back, feel free to do that as we go through these slides. I think we've got two more here, then we'll be done for today. All right, so here is very similar. If you remember in day one, we had one matrix equal to the other, and we just solved for x and y. Now we have to multiply. So we're actually going to get two equations here. So if I take this row times this column, I am going to get 10 plus 8a equal to 34. And if I do the same thing for the second row, I'm going to get 5b minus 56 equal to negative 6. From an algebraic standpoint, now you guys know how to solve that. So we did our multiplication first, row times column. Now I get a linear equation, and I can just solve for a and b. Sometimes you get a decimal. These two worked out to nice clean integers, positive integers, which was nice, but sometimes you will indeed get a decimal, and that's okay. All right, similar idea here. Again, multiplying, so row times column, so 2x plus 24 equal to 50, and 12 plus 3y equal to 46. And again, we can solve those for x and y. Like I said, sometimes you get a decimal. That's what happens here. So x works out to 13. Y is 11 and a third. All right, final slide for today. Again, this is kind of a continuation of what we had from the first day or review. So we have this matrix equal to B, and they tell us that B is this one right here. So again, just kind of review of those linear ones. No need to multiply here. We know that 3x minus 10 has to equal 8, and 2y minus 3 has to equal 17. So again, just a reminder, a review of the ones we had from day one, but worth the review for sure. Add 8, divide by 3, add 3, divide by 2. All right, so that completes your notes for section 2. Should be all set then to hit up that day 2 worksheet. And again, don't forget to check out the calculator tutorial as well. All right, thanks.